For our project, we decided to address the problem of storing and transporting surfboards. Typically, during transportation and storage of surfboards, the board's fins stick out of the board in a perpendicular fashion. This prevents the decks of the board from laying flat and flush upon each other. This configuration not only takes up more volume, but there is also the added fear of potentially damaging either the fin or other boards. The current design to counter this issue is removable fins, which have screws that secure the fins to the board. If an individual does decide to remove the fins in the event of storage or transportation of the board, this process usually takes around 1 minute for all 3 fins. Our solution to cut down on the time of fin removal and installation is to implement a folding fin system.
The sliding fin system is based off of spring design. When the fin is in the riding position, the spring is at its equilibrium length. To fold the fin into the locked position, it can be pushed forward, compressing the spring. Once the teeth of the fin clear the gap of the mount, it can be folded down. A bolt runs through the mount and the fin, holding the two together and serving as an axis of rotation.
An FEA analysis of both the fin and the mount were done using SOLIDWORKS. For the mount, the maximum stress was located along the inner base of the sidewall. A 6061 aluminum alloy was chosen because it was able to withstand the maximum stress, was lightweight, and could resist water damage. The maximum stresses for the fin occurred at the cutout of the base of the fin, but were much lower than the yield stress of the hard plastic material.
A flow simulation was also performed on the fin to analyze its hydrodynamics. Since the fin itself was modeled after a foil, the water flowed around it smoothly as anticipated. The folding mount, however, was expected to create disturbances in the flow, but to our surprise, the fluid streamlines reached a minimum of about 3.5 meters per second with an initial velocity of 5 meters per second.
It was time to build and assemble our product, so we headed to the machine shop and used the mill to machine down some raw aluminum stock that we purchased from the machine shop into our final components. We purchased a plastic fin from our competitor and used the mill to machine down the fin to our specifications so that it would fit into the folding mechanism. We also purchased a spring and bolt from McMaster-Carr to finish the assembly.
Moving forward, we would make a few changes to our prototype to optimize its performance and manufacturability. A smaller diameter pin would be used, the channel running through the mount would be wider, and the fin would be held statically in the folding position. Also, a better material would be used for the mount to help further resist water damage as well as remaining lightweight.
What a handsome guy you are!